we are going to discuss on this question which is present in lead coding December challenge, that is range sum of BST. So first of all, if we dive deep into the question, then what we get to know is that we are given a BST, that is binary search tree, and we are given the root node of the binary search tree, and there are two integer values which will be provided, that is low and high, and we need to return the sum of values of all the nodes with a value in the inclusive range of low and high. Like we need to include the value low and high also while calculating the range sum, and also we need to keep in mind that we are given with a binary search tree and with a given root node. So for example, if we look into this particular example which is given, we have a binary search tree. How we'll know that this is a binary search tree? We can know that this is a binary search tree by seeing that every node is having only two children. Only two children are there for every root node, and the value which is present in the left subtree of the root node is having the value less than the value of the root node, and the value which is present in the right subtree of the root node is having the value greater than the value present in the root node. So this is a binary search tree which will be given in the question. Okay, now we'll look into the examples. What are the examples given in the question? So the first example is this binary search tree, and we are having a root which will give you the complete binary search tree, and we are having two values, one is low and another one is high. Low is 7 and high is 15, and we need to return the output 32. So how will we return the output 32? We will traverse to this complete binary tree and we'll check that what all values are present in this tree, in this BST, which will have the values between 7 and 10, including 7 and 10. 7 and 15. We need to find out that what all values are present in this tree. So if we look into the example, so if we get into this particular node which is having the value as 10, we know that this value is more than low and less than high, that is, it is more than 7 and is less than 15. So we can add value 10 into the answer. So if we store the answer, then we can add this value 10 inside that answer. Then we will travel to this part and we'll check that whether this node is having the value include in the range of given low and high. So it is having the value 5, which is less than the low range given, so we cannot include this particular node. So what we'll do, we'll go to the next node and we'll check that whether this node is having the value which can be present inside the range. So we see that this can also be not included because it's having the value as 3, and that is less than the value of low range. And similarly, we'll go to this subtree, that this subnode which is having the value 7, and that is equal to the value of low range. So we can include 7 and add it to the answer, and then we can return back to the root node, and we'll go to the right part, and here we will check whether this satisfies the condition and this falls into the range which is given in the question. So 15 can be included because it falls in the highest range, so we can include 15 here. And we'll move further, we'll see 18. So 18 is out of bounds, so we cannot include 18, and then we will return back, and then we'll return back to the root node, and we will add all these values and we'll return the sum. So this will be adding 10 plus 7 is 17, 17 plus 15 is 32. We'll add and we'll return the answer 32 as the output. Similarly, if we look into the second example, we are having this BST and we are having the value low as 6 and 10 as high. So we can just take a variable sum to store the answer. It should be initialized with 0, and we are having low as 6 and high as 10. Okay, so what we'll do, we will travel to in this complete BST, and first of all we'll go to the root node, check whether it is null or not. So it is not null. Now what we'll do, we'll compare this value with whether it falls in between low and high. So 10 is the highest value, so we can include 10 in the sum. Then we'll go to the left part and we'll check whether 5 falls in the range. So 5 does not fall in the range, so we'll not include this particular node. Now we'll go to the left subtree. We'll check whether 3 falls in the range. So 3 also do not fall in the range given. We'll go to the left and check whether 1 falls in the range. So 1 also do not fall in the range. Now we will go to the left of 1, which is null. So when we'll get to the null, what we'll do, we'll just return, and after that we will go to the right of 1. We will see that this is also null. We will return. Now this particular method call is over, so we'll return. Now we'll go to the right of 3 and we'll see that this is null, and we'll return, and then we'll return back here. Now what we'll do, we will go to the right of 5 and we'll see whether 7 falls in the range. So yes, 7 falls in the range, so we will make it 17, add it to the sum and make it 17. Now we'll go to the left of 7. So when we'll go to the left of 7, we see 6. So yes, 6 also falls. 6 also falls in the range, so we will add 17 and then we'll add 6. Okay, and now we'll go to the left of 6. We will encounter null and we'll return back, and we'll go to right of 6 and we'll encounter null and we'll return back. Now the method call is over for 6, so we'll return back to 7. We'll go to the right of 7. This is null, so we'll return back, and we'll return back, and then we'll return back again. Now the left part of 10th node is done, so we'll go to the right part of 10th node. We'll check 15. So whether 15 falls in the range. So no, 15 does not falls in the range. So we'll go to the left of 15. We'll check whether 13 falls in the range. So 13 also do not falls in the range. We'll go to the left of 13, which is null. It will return back. We'll go to the right of 13, which is null. We'll return back, and then we'll go again to 15. Okay, we'll go again to 15, and then we'll go to the right of 15 and we'll check whether 18 falls in the range. So 18 also does not fall in the range. We'll go to the left of 18, that is null. We'll return back. We'll go to the right of 18. We'll encounter null, and then we'll return back, and then we'll return back to 15 again. And after coming back to 15, we'll come back to 10 again, because this method call is over. And after we'll get everything, we have already stored till then the value of the sum, which will be 23, and when we'll travel the complete tree, we'll get, after traveling the complete tree, we'll get the sum value as 23, and we'll return the value of sum here, which will be 23. Okay, so 23 will be the output. So for this particular thing to happen, we have a code which is written, and we'll look into the code now. The code is somewhat like this. We are having a global variable sum, where we'll store the value of the added values of the root nodes, which are having the value between the range given, between the low and highs. So, and as it is given in the question that low and highs should be inclusive, that is why when we get into this method traverse, we go and check whether the value is more than or equals to low and less than or equals to high. If it was not inclusive, we will not have included this equal to part. Okay, so first of all, we'll call this traverse method. What we'll do, we will just check whether the root is null or not. If it is null, what we'll do, we'll just return, and if it is not null, we will go through the value. We'll check whether the value is satisfying the range condition which is given in the question, and if it is satisfying the condition, then we will add the value to the sum. We'll add the value to the sum, and we'll update the sum variable. And after that, we will again recursively call this traverse method, and we will pass the root's left part, and we will pass the root's right part. And after traversing the complete BST, we will have the sum which will be updated, and will return the sum as the answer. So this is the basic Java solution, and if we look into the time and space complexity, we are having the time complexity which is O of n, and space complexity is O of h, where n is the number of total nodes which we are using and h is the height of the tree. So this is what we need to keep in mind, and that was all about the solution. Thank you so much.